All right, let's dive into data engineering for cybersecurity.
Okay.
Data is so important these days for any
No,
organization.
that's really the lifeblood, you know.
Yeah, protecting it is
It's mission critical these days, for sure.
absolutely, and to really get that security posture to where it needs to be,
Yeah.
you need that rock solid data engineering strategy.
You got it.
Um,
So, yeah, it's not just firewalls and intrusion detection systems anymore. It's
uh,
about leveraging that data
yeah,
as a weapon against cyber threats.
right.
Use it to detect, analyze, and respond to attacks quickly and precisely.
So we're moving from reactive security to a more proactive, data-driven approach.
You think of it like this. You wouldn't go into a battle without intel, right?
Right.
Data engineering is about gathering that intel, making sense of it, and turning it into those insights that can help you stay ahead of the bad guys.
That's a really good analogy because I've seen organizations really struggle to make sense of all the data they're collecting.
Yeah.
It's like they're drowning in information, but they don't have the insights to make informed decisions.
Yeah, that's a common challenge.
Yeah.
And that's exactly where data engineering comes in to bridge that gap between raw data and actionable security intelligence.
So let's break down this data engineering bridge.
Okay.
Where do we even begin?
Well, it starts with understanding the core principles of cybersecurity, particularly the CIA triad:
Okay.
confidentiality, integrity, and availability.
Oh, the CIA triad, the cornerstone of any security strategy.
You got it.
But how does that relate to data engineering?
Well, they're all interconnected.
Okay.
So you take confidentiality, for instance.
Yeah.
We're using encryption to protect sensitive data,
Right.
but to know what to encrypt,
Yeah.
you need to understand what data is valuable to your organization and where it is.
Okay.
That's where data engineering comes in.
So it's not just protecting data, it's also understanding the entire data landscape within an organization.
Exactly. And same goes for integrity and availability. Data engineering helps you to make sure that your data is accurate,
Right.
trustworthy, and it hasn't been tampered with, and it's available when you need it.
So the CIA triad isn't just some theoretical concept. It's deeply intertwined with how we approach data engineering.
Absolutely. And to implement the CIA triad effectively,
Yeah.
we need to focus on 3 security domains:
Okay.
protection, detection, and response.
Okay, let's break those down.
Okay.
So protection seems pretty straightforward.
Yeah.
It's preventing attacks from happening in the first place, right?
Strong passwords,
Yep.
firewalls, the whole 9 yards. But even with the best protection,
Yep.
some attacks are going to slip through the cracks.
Right.
That's where detection comes in.
So detection is about having the tools and processes to spot those attacks that get past our defenses.
Exactly. Intrusion detection systems.
Okay.
SIEM systems, or even XDR, which we'll touch on a bit later.
And response is having the right playbook to deal with the attacks once they're detected.
That's right. Incident response containment. Remediation, it's all about minimizing that damage and getting back to a secure state as quickly as possible.
Okay, so we have our 3 security domains: protection, detection, and response.
Yep.
But where does data engineering come into play with all this?
Data engineering underpins all 3 domains.
Okay.
It's about collecting, processing, and managing all that data generated by your security tools
Right.
so you can gain the insights and make informed decisions.
It sounds like data engineering is the glue that holds everything together.
It is.
It allows us to turn raw data into something useful for security operations.
Precisely. It's about building that data pipeline
Yeah.
that connects your security tools,
Okay.
data sources, and analysts,
Yeah.
allowing them to detect, analyze, and respond to threats with speed and accuracy.
Okay, so data engineering is the foundation for robust and proactive security.
Exactly. Now, to grasp how it works,
Yeah.
we break it down into 3 core pillars:
Okay.
data collection,
Okay.
data ingestion,
Okay.
and data management. We'll start with data collection, arguably the most critical piece.
So data collection is gathering all the raw ingredients for that cybersecurity intelligence.
Precisely.
Okay.
And it starts with asking the right questions.
Okay.
What data do we need to collect?
Right.
Where are we going to collect it from? How are we going to collect it?
Hmm.
How do we ensure that we're collecting it securely and efficiently?
Okay, let's unpack it. You mentioned what data.
Right.
How do we determine what data is valuable for our security goals?
That's a great question. It all depends on your organization's needs and risk profile.
Okay.
For some organizations, it might be focusing on user activity logs to detect insider threats.
Sure.
Others might be network traffic analysis to identify suspicious patterns.
So it's not a one-size-fits-all approach?
Exactly.
Yeah.
You need to tailor your strategy
Okay.
to your organization's security landscape.
Makes sense.
Once you know what data to collect, you need to figure out where to collect it from.
Right.
Endpoints, network devices, cloud platforms, applications. Each source offers a different perspective.
So we're casting a wide net gathering data from all corners of our digital ecosystem.
Yeah, you could say that.
Okay.
But it's also about being strategic. You don't want to collect everything under the sun and drown in a sea of data.
Right.
You need to be deliberate.
Yeah.
Align it with your security goals.
Okay, so we know what data we need and where to get it from. What's next?
The next step is figuring out how to collect it.
Okay.
Do you use agents on endpoints?
Ah,
Do you tap into network traffic?
okay.
Do you use APIs for cloud data or a combination of all three?
Yeah.
Each approach has its own pros and cons.
So this is where it starts to get a little technical. What are the key considerations for choosing a method?
One of the biggest challenges is scalability.
Okay.
As organizations grow, managing data collection across thousands of endpoints or terabytes of network traffic can be a nightmare.
It sounds like a headache.
Uh-huh.
So what are some best practices to ensure scalability in data collection?
One key is automation. Leveraging tools that automate the deployment, configuration, and management of those data collection agents can really reduce that burden on your team.
So it's taking the manual labor out of the equation.
Exactly. Another important aspect is choosing the right tools
Okay.
for the job.
Right.
There are a lot of data collection tools out there,
Yeah.
each with its strengths and weaknesses, some better for endpoint data collection, others for network traffic analysis.
Okay.
Selecting the right tool set for your needs is crucial.
So choosing the right tools and implementing automation are key for scalability and data collection. Anything else?
Yes, absolutely. Security and data separation,
Okay.
especially when you're dealing with multiple clients or environments, are critical considerations.
Okay, tell me more about that. Why is data separation so important?
Well, imagine you're managing security data for multiple clients,
Okay.
each with sensitive information. You need to make sure that data is kept separate
Right.
during collection and through the entire pipeline.
So it's about preventing data leakage and maintaining confidentiality and the privacy of each client's data.
Precisely. And there's several ways to achieve this.
Good.
One approach is to implement multi-tenancy,
Okay.
where data is logically separated at various levels, whether it's document level, index level, or cluster level separation.
Wow, data collection is much more nuanced than I initially thought. It's not just gathering data, it's gathering it securely and efficiently
You got it.
in a way that respects data privacy.
Yeah, and speaking of efficiency,
Yeah.
another important aspect is the concept of a fleet server.
Okay, a fleet server, what role does that play?
It's your command center.
Okay.
For data collection agents, a fleet server allows you to manage and monitor your agents,
Okay.
making sure they're collecting the right data, they're staying up to date, and they're operating efficiently.
So a single pane of glass to oversee all our data collection operations.
Exactly. That centralized management capability
Right.
is crucial for visibility and control over your data collection infrastructure.
Okay, so we talked about identifying the right sources,
Yeah.
figuring out where to collect the data from,
Yeah.
choosing the best methods for collection, ensuring security and scalability. What happens to all this data once we've gathered it?
That's a great question.
Yeah.
And that leads us into our next pillar, data ingestion.
Okay.
But before we jump into that, let's take a quick pause,
All right.
and we'll pick right back up in part 2.
Sounds good to me. See you all back here soon for part 2 of our data engineering deep dive.
Welcome back to our deep dive into data engineering for cybersecurity.
All right, so last time we left off talking about data collection,
Right.
which is gathering those raw ingredients for our cybersecurity intelligence.
Yeah.
Now it's time to talk about what happens next.
That's right. The journey doesn't end there.
Yeah.
We need to make sense of it.
Right.
And that's where data ingestion comes into play.
So if data collection is about gathering the raw materials, data ingestion is about refining those materials.
That's a great way to put it.
Okay.
Think of it as transforming raw logs and events
Yeah.
into structured, standardized,
Right.
and context-rich information that security tools and analysts can use.
It sounds like we're taking those puzzle pieces and sorting them out
Exactly.
to assemble the bigger picture.
Data ingestion is all about converting raw data into those actionable insights,
Right.
turning that sea of information into a map.
Okay, so let's break down this data ingestion process.
Right.
What are the key steps involved?
Well, the first step is parsing,
Okay.
which is breaking down the data into a structured format that
Mm.
our systems can understand.
Okay.
It's like deciphering coded messages,
Right.
extracting the meaningful information from those raw data streams.
So we're taking those cryptic log entries and making them something our security tools can read.
Precisely, we need to extract the fields, categorize the events, structure the data in a way that makes it usable. And this is where choosing the right tools comes in.
I imagine there were different tools and techniques available. How do we choose the right one?
It all depends on the type of data you're dealing with,
Okay.
the format it comes in,
Right.
and the complexity you're comfortable with. Some tools are for specific log formats.
Okay.
Others offer more flexibility and customization.
So finding that sweet spot between ease of use and the ability to handle the nuances of the data.
Exactly.
Okay.
And as you go, you might even explore things like regular expressions or custom scripting to handle those more intricate parsing situations.
Okay, so we've parsed the data and made it readable. What's next?
Next is normalization,
Right.
which is all about standardizing the data
Okay.
from different sources. Imagine trying to put together a puzzle with pieces from different puzzles.
Yeah.
It won't work very well. Normalization makes sure all those data pieces fit together.
So we're establishing a common language for all our security data.
Exactly. We need to harmonize those timestamps. Data formats naming conventions to create that unified view.
Okay, so we've parsed the data.
Right.
We've normalized it.
Yep.
Is there anything else we need to do before we can start using it?
Yes. One more critical step, enrichment.
Okay, enrichment.
This is where we add that valuable context,
Oh, yeah.
turning those raw events into meaningful insights.
Right.
It's like adding the extra layers of detail that transform data into intelligence.
So we're fleshing out those bare bones events
Precisely.
with more information.
Enrichment can involve adding information from threat intelligence feeds,
Okay.
geolocation databases,
Okay.
user directories, and a lot of different sources. This helps answer questions like,
Yeah.
is this IP address known for malicious activity?
Right.
Or is this user accessing data they shouldn't?
I see how enrichment can really improve our security.
It is.
It's like going from those black and white security logs to full color HD.
That's a great way to put it. Enrichment is adding that depth and meaning to the data, enabling us to detect those patterns, identify those anomalies,
Okay.
and make informed decisions.
So we've covered parsing, normalization, and enrichment. The three keys steps in data ingestion.
We have.
But it doesn't end there, does it? Now we have this wealth of data. What happens next?
That's right. The data has been collected, ingested, refined, and is now ready to be used.
All right.
And that brings us to our next pillar, data management.
Great.
But just like with data ingestion, there are a few crucial steps.
This is where things get really interesting. We have all this data, but how do we store it and organize it and make sure we can access it?
Exactly. Data management is all about building a structured library
Okay.
where we can find the information,
Right.
protect it from unauthorized access, and make sure it's accessible.
Yeah.
And one of the first things is indexing.
Indexing, that sounds familiar. It's like creating a catalog for our security data.
Precisely just like a library catalog.
Right.
A robust indexing strategy lets you find what you need. It allows analysts to sift through vast amounts of data to find those patterns, anomalies, and threats.
So it's not just storing the data, it's organizing it to make it searchable.
Exactly. And there are different approaches to indexing, each with its own strengths and weaknesses.
Okay.
Some are optimized for speed, while others prioritize flexibility or storage efficiency.
So choosing the right strategy depends on our specific needs.
Exactly.
Okay, so indexing is about making our data searchable. What else?
Another crucial aspect is data retention.
Okay.
We need to figure out how long to keep our data
Right.
based on compliance requirements, business needs, and storage limitations. We can't keep everything forever.
So striking a balance between keeping enough data for analysis and managing storage costs.
Exactly. You need to have data retention policies that align with your organization's risk tolerance
Okay.
and regulatory obligations. Some data needs to be kept for years for compliance, while others might only be for months or weeks.
All right. Retention makes sense. What about storage itself?
Yeah.
How do we choose the right solution, especially considering the volume of data?
That's a great question. Storage is key, and it often comes down to balancing performance cost and scalability.
Okay.
We need to consider things like data access frequency, performance requirements, and cost.
So some data needs to be readily available for real-time analysis, and others can be archived.
Exactly. Data that needs to be accessed quickly is referred to as hot data.
Okay.
Think of those recent events that need to be analyzed immediately. This type of data needs those fast, high-performance solutions.
But what about the data we don't need to access as often?
Right, that can be archived to more cost-effective cold storage.
Okay.
These solutions are optimized for storing large volumes of data that are accessed infrequently.
So different tiers of storage for different types of data.
Exactly, and there are a lot of storage technologies out there,
Yeah.
each with their own strengths and weaknesses. Choosing the right mix is important for balancing performance cost and scalability.
So we're building this ecosystem of data pipelines, storage, and indexing to make sure we can access our data. But what happens if we lose data?
That's where backups come in.
Okay.
Absolutely essential for any data management strategy,
Right.
especially in cybersecurity. Regular snapshots of your data
Yeah.
ensure that you can recover quickly, whether it's a system failure, cyber attack, or accidental dilution.
So backups are an insurance policy for our data.
Exactly. They provide that extra layer of protection,
Okay.
giving you peace of mind that you can restore your data. And there are a few backup strategies.
Yeah.
You can implement from full backups to incremental backups or continuous data protection.
So we've talked about storing and organizing data,
Yeah.
but what about using it for security operations? How do we analyze all this information?
That's where things get exciting.
Okay.
And we'll dive into that in the final part of our deep dive.
Can't wait to uncover those final pieces. See you all back here soon. Welcome back, everyone, to our deep dive on data engineering for cybersecurity.
We're in the final stretch now.
Yeah, we've gone from those raw logs and events to structured, enriched data.
Yeah, ready to be used.
Ready for action, organized, stored for access. But now the exciting part.
Yeah, putting it to work.
Putting it to work. Last time we talked about how we use this data for security operations.
Right, that's the key. How do we unlock the potential of all this data?
Yeah.
And a critical part is having an efficient way to search through it.
Okay.
Find those insights in all the logs and events.
So pinpoint those needles in the haystack.
Yeah,
Those anomalies that signal an attack.
exactly. And that's where a fast search API comes in.
Okay.
It's like having a super speedy librarian who can find any book you need instantly, no matter how big the library is.
So speed and efficiency, being able to search through all of it in a snap.
Huh.
How do we achieve that?
Well, there are a lot of search technologies and indexing strategies designed for huge amounts of data.
Okay.
Some use distributed search architectures.
Okay.
Others are optimized for specific data types or queries.
So it's about choosing the right technology and designing our indexing strategy to meet our search needs.
Exactly. And it's more than just basic keyword searching.
Yeah.
We're talking complex queries, filtering by criteria, correlating events, and even visualizing patterns.
Wow, it's like having this powerful search engine that can answer any question about our data instantly.
Yeah.
But it sounds like it takes a lot of planning to get it right.
You're absolutely right. It's not easy to implement a fast and efficient search API.
Yeah.
It takes an understanding of the technologies, the indexing strategies, and data modeling, but the payoff is huge.
So with the right expertise and planning, we can really use this data to boost our security, but search is just one piece, right? What else can we do with all this data?
Well, one area with huge potential is threat intelligence and proactive threat hunting.
Okay, threat intelligence and threat hunting, those sound pretty intense.
They are, threat intelligence is about gathering information about potential threats,
Okay.
understanding those attacker tactics and techniques, and using that knowledge to inform our strategies.
So it's like having a spy network that keeps us informed about the latest threats so we can stay ahead.
Exactly. And data engineering was a big part of that.
Okay.
We can use our data to identify patterns, track behavior, and even predict future attacks.
Wow. Predict future attacks. That sounds like something out of a movie. How's that even possible?
Well, with the right data and analytical tools, we can start to see those indicators that come before an attack.
Okay.
And by analyzing historical data, we can identify those patterns and anomalies that could mean a threat is coming.
So we're not just reacting to attacks, we're using data to anticipate them and prevent them.
Exactly. And that's where threat hunting comes in.
All
That's
right.
about proactively searching for signs that might have gotten past our defenses,
Okay.
like a detective using our knowledge and tools to find those hidden threats.
So we're actively looking for attackers that might have gotten through.
Exactly. Threat hunting is a proactive approach using data tools and expertise to stay ahead.
This is eye-opening. It's like data engineering helps us move from reacting to attacks to preventing them.
That's it. It's about changing our mindset from responding to hunting and preventing.
This has been great. We've gone from gathering data to analyzing it, visualizing it, and using it to defend against threats. But one more thing, automation.
Yeah.
We've talked about it a lot, but how is it changing data engineering and cybersecurity?
It's a game changer. It's about making things more efficient, reducing manual work and letting our security teams focus on what matters.
So automating data collection analysis and even response?
Exactly. And there are lots of tools and technologies that can help us with that.
Okay.
And as machine learning and AI keep getting better, there will be even more we can automate.
That's really cool. So automation is the key to making data engineering even more powerful for cybersecurity.
It is. By using automation, we can create a better and more proactive security posture so we can keep up with the threats.
It's been an awesome deep dive. I feel like I understand how important data engineering is for the future of cybersecurity.
It's been great to share this with you, and remember, the future is in our hands. By mastering data engineering, we can make a safer digital world.
So to everyone listening, think about how you can use data engineering to improve your own cybersecurity.
What can you do to protect your organization, anticipate threats, and make a better digital future?
The possibilities are huge, and it all starts with data.
Thanks for joining us on the deep dive.